Okay, what if I told you that the entire universe, from the tiniest atom to the absolute biggest galaxy, operates on a kind of hidden rhythm? A simple pattern of 3, 6, and 9 that might just hold the key to solving one of the biggest mysteries in all of cosmology. Let's dive into this pretty radical idea. Our story really kicks off with a puzzle. It's a puzzle that has left scientists scratching their heads for decades, a magnetic mystery that's written across the very fabric of space and time. If you look at almost any galaxy out there, including our very own Milky Way, you'll find this gigantic, powerful magnetic field stretching across hundreds of thousands of light years. It's just there. The question is, how did it get there in the first place? See, this whole puzzle has a name. It's called the magnetic seed problem. To grow a magnetic field that big, as vast as an entire galaxy, our current understanding of physics says you need a smaller one to get it started. You need a seed. But where did that first seed come from? So let's break this down. Right now, we see these huge, well-organized magnetic fields everywhere. But if you rewind the clock to the early universe, it was a completely different story. It was this incredibly hot, chaotic soup. Any magnetic fields back then should have been just as random and messy. So how do you get from that total chaos to the incredible order we see today? That right there, that's the core of the whole mystery. So the answer might not come from the physics we already know. It might come from a totally new way of looking at things, a framework that suggests there's a hidden rhythm to how the universe actually works. This question, posed by researcher Kevin L. Brown, is really the jumping-off point for this whole idea. What if the universe doesn't just change randomly? What if it follows a very specific repeating pattern for, well, everything? And that idea has a name. Triune Harmonic Dynamics, or THD for short. It's basically a proposed framework that says everything that changes or evolves, whether it's a tiny cell or a whole galaxy, does it in a predictable 3-step cycle. At the heart of it all is this really simple repeating cycle. First, something new emerges. A new state is born. Second, that new state gets tested by opposing forces. That's the contrast phase. And third, those forces eventually resolve and integrate into a new higher level of order. And then, the cycle just starts all over again. Now, this isn't just some philosophical concept. It's actually grounded in mathematics. This equation you're seeing here, it's the mathematical description of how that 3-phase cycle of transformation unfolds. And when you map it out, you find an underlying pattern of, you guessed it, 3, 6, and 9. Okay, so that's the theory. We have this idea of a universal pattern. But how does a 3-6-9 rhythm actually help us solve the cosmic magnetic seed problem? Let's connect the dots. All right, so the standard model of cosmology says that magnetic fields had to grow really, really slowly, taking billions of years to build up from some tiny unknown seed. The THD model, though, suggests something totally different, a rapid phase lock, where a huge orderly field could have snapped into existence almost instantly. They call this a geometric phase lock. So try to picture the crazy, turbulent plasma of the early universe. The THD theory suggests that once it hit a certain threshold, all that chaotic motion could have suddenly just synchronized. It's kind of like a huge crowd of people clapping out of rhythm, and then all at once, they all start clapping together perfectly. That sudden alignment could create a massive, coherent magnetic field, essentially out of nothing. And this all leads to the theory's most important and, crucially, testable prediction. It says that the strength of a magnetic field, which we call B, should be directly proportional to how fast the system is rotating, or omega. It's a simple, elegant relationship that should hold true for everything, from planets to stars to entire galaxies. Now, for any new idea in science, this next part is maybe the most important part of all. It's not enough to have a cool theory, you have to be able to test it. You have to have a way to prove it's wrong. This is a core principle in science called falsifiability. It's really the line in the sand between science and just speculation. If you can't even imagine an experiment or an observation that could disprove your idea, then it isn't really a scientific one. So the great thing about THD is that it makes very clear, very testable predictions. First, it predicts that if we look way back in time at the universe's very first galaxies, they should already have strong, mature magnetic fields. Second, that direct link between rotation and magnetism should be something we can see everywhere we look. And third, we should find evidence of large-scale magnetic order way back then, not the chaotic mess that the standard models expect. And here's the flip side, the specific conditions that would prove the hypothesis is wrong. If we find that those early galaxies actually have really weak or basically no magnetic fields, the theory is wrong. If we look everywhere and we can't find that consistent link between rotation and magnetism, the theory is wrong. And if the early universe's magnetic fields turn out to be completely chaotic after all, well, that would totally disprove the idea of a rapid phase lock. It's that clear-cut. So this all brings us to the really exciting part. We actually won't have to wait very long to find out if this new cosmic rhythm is for real. The tools we need to test these predictions are literally coming online as we speak. The real testing window opens up around 2026. The main tool for the job is going to be the Square Kilometer Array, the SKA, which is this massive new radio telescope. By about 2030, scientists expect we'll have enough data to either find evidence that supports TD's predictions or to falsify them for good. And of course, it's really important to give credit where it's due. This entire framework, from the concept of triune harmonic dynamics to these specific falsifiable predictions about cosmic magnetism, was all developed by the researcher and author Kevin L. Brown. So while we wait for that data to start rolling in, we're left with this really profound question. Is all the chaos we see in the universe just one phase in a much larger, structured, repeating pattern? Is the entire cosmos, from the smallest particle to the biggest galaxy, actually humming along to a single, universal rhythm of 369? We might just find out the answer in the next few years.